Okay, so is one of the speakers for the Netflix paper here? Oh, excellent. All right, I didn't see you there. Okay, so our next paper, joint modeling of search and recommendation via unified contextual recommender. This is one of our industry papers, and we have Moumita Bhattacharya to present.
Nice to see you again, Dr. Brook. Hey everyone, thank you so much for staying for the last talk of the session. I'm Moumita Bhattacharya, a senior research scientist at Netflix, working in the search, recommendation, and foundation model space. And today I'm excited to talk about a joint work that I did with my Netflix colleague, Vito and Sudarshan, on jointly modeling search and recommendation task, the model that we call UniCoRn, Unified Contextual Recommender. As we all know, there's multiple applications of search and recommendation across the industry in different products. Here's an example of some task of search and recommendation in the context of Netflix. The first task that I'm showing here is query to video recommendation, which is essentially traditional search. Then we can also have purely personalized recommendation. The screenshot here is from no query recommendation task, which is the recommendation that comes up when you click on the magnifying glass on Netflix. Then we can have a different kind of recommendation, like video to video recommendation, title recommendation, where the context is when you click on a video, you see other similar videos to that. All of these are search and recommendation tasks. And the question, the thesis we try to answer in this work is, do we need individual bespoke models to solve these tasks? Or can one model solve both the tasks or multiple of these tasks? And the answer is yes. We embark into this journey of building one model that can do both traditional search and personalized recommendation, and this talk is about that. First, let's dig into what is the difference between these different kind of tasks. We would argue that the first major difference is the context. For example, when it's traditional search task, query is an important part of the context. We type a query, we expect the results to respond to that query. That's traditional search task. Title to title recommendation, the context is the entity or the video that you click, Stranger Things, you want to see more similar titles to Stranger Things. So the context is the biggest difference between these tasks. Then the data itself is also different. On different parts of the product, these tasks or these recommendations and search results are shown. As a result, users' engagement with them is also different. So the positive engagement with the different parts of the product leads to different data. Additionally, the candidate set, or the retrieve candidate, is also different. We could have canvas-specific or task-specific retrieval logic. There might be some conditions that we can show certain kind of titles on some part of the product. And finally, there is, as many of us in industry know, there is often business logic or post-ranking, re-ranking that happens, some kind of filtering or some kind of business logic. So what we set out to do here is we wanted to develop one single recommendation model, a contextual recommendation system that can then serve search and recommendation tasks, specific type of recommendations at least. And we hypothesized that here are some benefits of being able to do that. First is, we thought, and we proved, that these different tasks will benefit from each other. So the search task and the recommendation task will actually help each other. The second is a very big one, where any innovation applied on one of these tasks will automatically apply on other tasks. So let's say personalization. If you personalize this unified ranker, then it will impact the task of search as well as recommendation, title recommendation, and purely personalized recommendation. And a huge benefit, many of us in industry will hopefully agree with me, is low maintenance cost and reduced tech debt, which is a pretty big deal. For 4 different tasks, instead of maintaining 4 bespoke models, we have to maintain one model. Do maintenance, there's also reduction of the compute cost as well. So how did we approach this? We unified the differences. So we unified the context to begin with. We made the context much larger. So instead of a search task which has query and potentially other contexts like country and language, so whether it's English versus Korean, we decided to make the context of this model very large and aware of all these different task-related contexts. For example, in the context of UniCoRn, this unified contextual recommender system that we built, the context is query, country, entity, where entity could be in catalog video, but the entity is also beyond that, where we can take into account the collection, like genre, or the person, the cast of the shows or the movie, out of catalog titles, and so on. And we also incorporate the task type in the context. An example context here for search task is query, country, language, and the task equals to search. Similarly, for title recommendation, it's source video, country, language, and task is title recommendation. And as you can see, there is extensibility in this approach, where the additional context can be added while specifying the task that it serves. And we also combine the data that is coming from all these different parts of the product. In a way, it's kind of data-driven multitask learning approach, where we merge all the data, but the engagement, where it is coming from, which task is coming from, is being informed by the model, to the model. And ultimately, something that was already unified was the target. Whether it's query to video ranker, whether it's title to title ranker, whether it's purely personalized ranker, it ultimately is trying to rank the videos in the context of Netflix. So the target itself is the engagement on the corresponding title given the context. So here's the very high-level setup of the model itself, which is essentially a multitask setup via model sharing, where we have features that are pertinent to entities itself, entities, for example, video, in catalog video. Then we have features specific to context. So for example, when the context is query, we have lexical features, we have query-relevant features. When the context is source, and like video ID, we have video-related features. And very powerful features are also the context and entity cross features. And as you would imagine, we have a set of numeric features, as well as for each of these categories, we also have categorical features. And those categorical features, we learn embeddings. Ultimately, it's a binary classification task, so we use binary cross-entropy loss and Adam optimizer. And this model, given the context and given the task, it learns to predict the positive engagement. And that's where it becomes unified, because we are kind of feeding the model, automating this aspect of what task or what is the context, and give me the set of video ranked set of videos. Let's look a little bit into how is this magic happening. Here are some pointers as to why this has been working. We have it productized on our Netflix product for some time. Each of these tasks benefit from the auxiliary tasks. So this was also our hypothesis that this will happen, and we are seeing that the different tasks are helping each other. Then the task type in the context, as well as features specific to the task, has been quite helpful and has helped us trade off between these different tasks. Also, imputing missing context. So for example, in the context of search, we have query, but in the context of title recommendation, we don't have query. Figuring out ways to impute missing context has helped improve the feature coverage, which has ultimately helped learn across different tasks. Also, things like feature crossing has helped. Ultimately, with this unification, we were able to achieve either a lift in performance for each of the tasks or even improvement on different tasks in the first version of this unified model. And then I want to show you something that goes into deeper of one of the advantage, which is we can bring additional innovation to multiple tasks once we innovate on this unified model. Here's an example where we personalize this unified recommender system, and we got the personalization effect on multiple different canvases or multiple different tasks. So we had a separate model where we are learning user long-term preference. We basically figure out a way to merge information of this user long-term preference into this unified contextual recommender. And magically we got personalization on search, on more like this, on purely personalized tasks like pre-query. And again, this is extensible to other canvases as well. And this personalization effort also gave us a 7% lift offline with respect to search task. And for one recommendation task, it gave us 10% lift. And the beauty was that during inference time, we still have that one model, which is now automatically bringing in personalization to multiple different tasks. Here's an example. Let's say the query was S. For my profile, where I don't watch too many kids' content, before personalization, I was seeing some kids' content, even though it was lexically relevant titles, but they were not personally relevant. With this personalization into UniCoRn for the search results, it kind of got updated, and the kids' title were removed, and all the results became more relevant. And there are similar examples for other tasks, like more like this, or title recommendation. So what were some of the considerations that we had to keep in mind? One big consideration is, because all these tasks are very context-driven, there is always a trade-off between relevance and personalization. We cannot ignore relevance and over-personalize something like search, right? Because then we'll lose the context of the query. So how we think about the model architecture, how we think about the features and the informing the model of these different contexts, taking into account personalization relevance trade-off was very important. Latency and throughput is super important, latency especially, given it's all real-time context. And handling missing context was important, feature specific to a context, and finally, task-specific retrieval logic, thinking through that was also important, even though in this particular area of work, we did not unify the retrieval logic yet. All right, I just had 10 minutes, so concluding remarks. We see that a single unified model aware of diverse contexts can indeed perform equally and improve both search and recommendation tasks. Incorporating personalization within the unified model benefits applications while optimizing trade-off between relevance and personalization. And several infrastructural considerations such as latency and modeling considerations such as feature crossing, et cetera, had to come together for us to be able to build this one unified model that can serve both search and recommendation. And huge shout out to all my colleagues, especially my co-authors, Vito, Sudarshan, and Roger, who are here. And this work wouldn't have been possible without the stunning Netflix colleague. I will take any questions if there are any. And before that, there's a PSA. Tomorrow we have a Netflix session at 12 o'clock in wherever the booths are. Come see more work from Netflix.
All right, let's thank our speaker. All right, we do have a couple of questions. And so this has to do with kind of the interaction between the tasks and kind of the different semantics of, say, search versus, other kinds of personalized recommendation. It seems that does the model actually learn that, maybe the recommendation task is going to entail more exploration, or is there kind of a way in which that actually makes the search worse, that you're using it for multiple things? How does that happen?
So just to reiterate your question, how are we not hurting one task while improving the other task, or what are there considerations that we are taking into account when search?
Well, this kind of semantics of the interaction are a little bit different, and you're trying to put them into the same model. So how do you achieve kind of the differentiation that you need?
Yeah, I think there are three things that plays a role here to make sure that it's not hurting, the semantic of one context is not hurting another. One is the context-specific features are informing the model to learn that trade-off between context. Things like specific to features, I guess feature space, feature crossing, what kind of embeddings we are learning for different contexts, and the context and entity cross features also help. Model architecture, how we merge the personalization part of the graph to the rest of the relevance part of the graph. Unfortunately, I was not allowed to talk a lot about the architecture, but how we think about not over-personalizing or keeping the relevance intact. So the design of the model architecture comes into play as well.
Okay. Yeah, very interesting. All right, let's thank our speaker again.
Okay. By the way, is this the last talk?
What's that?
Is this the last talk? Is this the last talk?
No, it's not the last talk, unless the speakers for paper number 2 are not here. So, and that is what I am not sure about. So, do we have any of the presenters